Hello students, the question is 12 negative charges of same magnitude are equally spaced and fixed on the circumference of a circle of radius capital R as shown in figure 1. Relative to potential being 0 at infinity, find the electric potential and electric field at the center C of the circle. This is the first part of the problem. The second part is if the charges are unequally spaced and fixed on an arc of 120 degree of radius capital R as shown in figure 2, find the electric potential at the center. So in this particular problem, there are two parts. First part, we have to find out the electric potential at point C as well as the electric field at point C. Here, 12 charges are placed equally spaced. In the second part of the problem, we have to find out the electric potential at the point C. Here the charges are unequally spaced. तो इस पर्टिकुलर प्रॉब्लम में दो पार्ट हैं. पहले पार्ट में कहा गया है एक सर्कल के पर्टिकुलर पेरिफेरी पे 12 इक्वली स्पेस्ड पॉइंट्स पे सर्टेन चार्जेस हैं और उन चार्जेस की वजह से हमें सी पॉइंट यानी इसके सेंटर पे इलेक्ट्रिक फील्ड और इलेक्ट्रिक पोटेंशियल कैलकुलेट करना है. इस सर्कल की रेडियस कैपिटल आर है. दूसरे पार्ट में हमसे कहा गया है कि अगर ये सारे 12 चार्जेस 120 डिग्री के एक पर्टिकुलर आर्क के ऊपर प्लेस्ड हैं, अनइक्वली स्पेस प्लेस हैं, तब इस केस में इलेक्ट्रिक पोटेंशियल क्या होगा. So this particular problem is based on the topic electric potential and electric field. The electric potential and electric field due to a certain charge or a combination of charge. In this particular case, there are the combination of charges. So we have to use the principle of superposition. Now let us solve this particular problem step by step. So in the first part of the problem, we have to find out the electric potential at point C as well as the electric field for the figure 1. So in the figure 1, there are 12 charges, total 12 charges placed at an equal distance on the perimeter of this particular circle. So the situation is this, 12 equally spaced charges are there. We know that the electric potential is given by the formula V equals to 1 upon 4 pi epsilon naught Q upon R. Suppose we have to calculate the potential at a point P due to a certain charge placed at this particular point, and the distance between them is R. So this is the formula to calculate the potential. The formula to calculate the electric field is E equals to 1 upon 4 pi epsilon naught Q upon R square. So this is the particular case where we have to find out the electric field as well as the potential. We have to find out both the things for this particular figure 1. So, and the electric field, there is also a direction corresponding to it. For example, direction, we place a unit vector n cap. The direction is away from the point if the charge is positive, and towards the point where the charge is placed if the charge is negative. So in this particular problem, the charges are negative in nature. So for negative charges, suppose this is charge number 1, this is charge number 2, and so on up to charge number 12. So there are total 12 charges. So the potential, total potential due to all the charges is the net sum of all the potentials. For example, V1, V2, V3, V4 and so on up to V12. So we have to find out the potential at for corresponding to the each charge, and we have to make the sum of it. Now we know that potential is a scalar quantity. There is no direction corresponding to the potential. So straight away we can say that the total potential is given by 1 upon 4 pi epsilon naught bracket minus q plus minus q plus minus q and so on minus q 12 times. So we have to add these minus q charges 12 times. So finally, and upon r, where r is the distance of the point where which we have to calculate the potential due to the charge. So we can say that this comes out to be 1 upon 4 pi epsilon naught minus 12q upon r, or we can say that minus 12q upon 4 pi epsilon naught r. So this is the value of the total potential at the point C in this particular figure due to all the charges. So this is the potential, value of potential. Now let us analyze the second thing, which is the electric field at the point C. To calculate the electric field, we take the help of the symmetry of this particular figure, the symmetrical placement of the charges. For example, let us take the charge placed at point 12. This is the point 12 where the first charge is placed. So diametrically opposite to this particular point, there is point 6. There is also a charge, same charge. Now the charges are same in value. The distances of the respective charges from the center is also same. So we can say that the electric field is also same. So suppose the electric field due to the charge placed at point number 12 is given by E equals to 1 upon 4 pi epsilon naught. Generally, we put the letter K in place of 1 upon 4 pi epsilon naught. In most of the text, they use the letter K. So K Q upon KQ upon R square. So this is the value, this is the particular amplitude of the electric field due to the charge placed at point 12. And the direction of the electric field is towards the point 12. Similarly, for the charge placed at the point 6, the electric field is towards the charge 6 and the magnitude is same as that the magnitude of E12, that is the charge placed at 12. So we can say that E6, modulus of E6 is equal to KQ upon R square, whereas the directions are exactly opposite. So we can say that this particular field cancels this particular field. E12 cancels E6. Similarly, E1 cancels E7, E2 cancels E8, E3 cancels E9, E4 cancels E10, and E5 cancels E11. So in this manner, we can say that all the electric fields are cancelled out, or the total electric field is zero due to the symmetry of the placement of the charges. So we can say that electric field, net electric field is zero in this particular figure due to the symmetrical placement of charges. They cancel each other. The diametrically opposite placed charges cancel each other. So in this way, the net electric field is zero in the first case. Now, the second part of the problem, in the second part of the problem, the charges are placed on a on an arc on an arc of 120 degrees, and these are unequally spaced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 charges, they are unequally spaced, not equally spaced, unequally spaced. And we have to calculate the electric potential only. In this particular problem, we have to answer the electric potential only, V. So V is given by minus 12 Q times K, where K is 1 upon 4 pi epsilon naught into K and upon R, or we can say that capital R, because the radius of the circle is capital R. So we can say that the potential is same in this case also, because potential is a scalar quantity. Potential is a scalar quantity. That's why the answer, this particular answer, the first part of the problem is same as the answer of the second part of the problem. So the potential is minus 12 Q. K means 1 upon 4 pi epsilon naught upon R. So the answer is same for the potential. Electric field is not asked in this particular part, because there is a non-symmetry, and the exact placement we do not know. And if we do not know the exact placement of the charges, we can't calculate the electric field here. So this is the explanation of this particular problem. In the first part of the problem, the answer is minus 12 Q upon 4 pi epsilon naught R. This is the value of total potential at point C. And the electric field, net electric field in the first case is 0. And the second part of the problem, when the charges are unequally spaced, then we can say that the potential is same as this expression. Either you write the expression in terms of K, or you can write minus 12Q upon 4 pi epsilon naught R. So this is the final answer. So यहाँ पे इस पर्टिकुलर प्रॉब्लम में हमसे दो पार्ट में पूछा गया है. पहले पार्ट में एक सर्कल के अलग अलग पॉइंट्स पे चार्जेस रखे हैं, इक्वली स्पेस रखे हुए हैं. इनकी वजह से हमें पहले निकालना है पोटेंशियल, टोटल पोटेंशियल, फिर निकालना है हमें इलेक्ट्रिक फील्ड. यहाँ पे हम प्रिंसिपल ऑफ सुपरपोजिशन का यूज करेंगे. हम रेस्पेक्टिव हर एक चार्जेस की वजह से पोटेंशियल निकालेंगे, और टोटल पोटेंशियल हम उनका स्केलर सम करेंगे, क्योंकि पोटेंशियल इज अ स्केलर क्वांटिटी. और हमें जानते हैं पोटेंशियल कैलकुलेट करने के लिए फॉर्मूला होता है 1 अपॉन 4 pi epsilon naught Q upon R. वेयर क्यू इज द रेस्पेक्टिव चार्ज जिसकी वजह से हम पोटेंशियल निकाल रहे हैं, और आर वो दूरी है उस पॉइंट पी की चार्ज से। तो यहाँ पे हम ये पर्टिकुलर फॉर्मूला यूज कर रहे हैं, और इस फॉर्मूले में हमने V1, V2, V3 एंड सो ऑन अप टू V12 तक निकाला और इन सबको सम कर दिया। तो जो टोटल सम आया V इक्वल्स टू -12Q/4 समझ आता है। इलेक्ट्रिक फील्ड कैलकुलेट करने के लिए हम ये कंसेप्ट यूज करेंगे कि ये सिमेट्रिकली प्लेस्ड चार्जेस हैं, और अगर हम ध्यान से देखें तो डायमेट्रिकली अपोजिट एंड पे जो चार्जेस हैं वो एक दूसरे के फील्ड को नलीफाई कर रहे हैं, कैंसिल कर रहे हैं। अगर आप ध्यान से देखें तो 12th पॉइंट पे जो रखा हुआ चार्ज है उसकी वजह से इलेक्ट्रिक फील्ड की डायरेक्शन टुवर्ड्स दिस चार्ज इस तरह से। ऐसे ही 6 पॉइंट पे जो रखा हुआ चार्ज है उसकी वजह से सी पॉइंट पे जो फील्ड है उसकी डायरेक्शन जो है वो टुवर्ड्स द पॉइंट 6 है, और ये दोनों एक दूसरे के डायमेट्रिक एक दूसरे को कैंसिल आउट कर रहे हैं, एक ही लाइन पे लाई कर रहे हैं लेकिन अपोजिट डायरेक्शन के हैं, इनके मैग्नीट्यूड सेम है तो इसलिए एग्जैक्टली कैंसिल कर देंगे। सिमिलरली 1 पे जो रखा हुआ चार्ज है उसकी वजह से सी पे जो फील्ड है वो कैंसिल हो जाएगा 7 पे जो रखा हुआ चार्ज है उसकी वजह से फील्ड से, और इस तरह से जो है सारे चार्जेस के जो डायमेट्रिकली अपोजिट पॉइंट पे रखे हुए चार्जेस हैं वो एक दूसरे के फील्ड को कैंसिल आउट कर देंगे। तो हम कहेंगे कि नेट इलेक्ट्रिक फील्ड हमारा इस केस में क्या होगा, 0 होगा। दूसरे पार्ट में कहा गया है कि ये चार्जेस जो हैं एक सर्कुलर आर्क के अलग अलग पॉइंट्स पर रखे हुए हैं, और ये अनइक्वली स्पेस्ड रखे हुए हैं, और हमें पोटेंशियल पूछा जा रहा है। तो पोटेंशियल निकालने के लिए हमें इनकी डायरेक्शन से कोई कंसर्न नहीं है, इनके प्लेसमेंट से कोई कंसर्न नहीं है, केवल हमें दूरी से कंसर्न है कि उनकी दूरी रेस्पेक्टिव जो है उस पॉइंट सी से कितनी है, और वो सेम है आर के बराबर। तो यहाँ पे जो हमारा आंसर है वी का वो सेम रहेगा जैसे हमारे फर्स्ट पार्ट में आंसर आया था -12Q/4 यही आंसर पोटेंशियल का होगा सेकंड केस में भी। होप आपको एक्सप्लेनेशन समझ में आई होगी।